Hi, this is Algebra 2. We're doing lesson 82, which is Algebraic Simplification, and we're starting on page 339. There are three rules in algebra that we use the most often. The first two apply only to equations. Number one, the same quantity can be added to both sides of an equation without changing the value of the solutions of the equation. So if we have x equals y, then we can say that x plus 2 equals y plus 2. Number two, every term on both sides of an equation can be multiplied by the same quantity except 0 without changing the value of the solutions to the equation. So if x equals y, then 2x equals 2y. The third rule applies to individual terms of an equation and can also be used on expressions that are not in an equation. With few exceptions, unless an equal sign is present, this is the only rule that can be used. The denominator and numerator of an algebraic expression can be multiplied by the same quantity except 0 without changing the value of the expression. This is called the denominator-numerator rule. So x over y equals 2x over 2y. Okay? In lesson 64, we found that an expression such as a plus 1 over 1 plus 1 over x can be written as a simple fraction by using the denominator-numerator rule several times. So to do this, we're going to start by simplifying the denominator of the complex fraction. Remember, you always start with the most complex fraction and start in the denominator. Okay, so we're going to start with the denominator. So we have 1 plus 1 over x. We're going to find the common denominator here, which is going to be x. So we're going to multiply the top and bottom here times x. We get x over x plus 1 over x. And then we can rewrite this as x plus 1 over x. Right? Okay, now we're going to put this back in. We have a plus 1 over x plus 1 over x. And now we can multiply the top and bottom by the inverse of the denominator. Right? So this cancels, and we get a plus x times x plus 1. And now we need to find a common denominator in order to add these terms together. So the common denominator is going to be x plus 1. So we're going to multiply the a times x plus 1 over x plus 1. So we have a times x plus 1 plus x all over x plus 1. Right? And now we're going to simplify by pulling things out of the parentheses. So we have ax plus a plus x all over x plus 1. Okay? And that's going to be your answer. Okay? Here's one that's a little more complicated. We have a over 1 plus a over 1 plus 1 over x. Okay, we are going to once again start by simplifying the bottommost denominator and work our way up. So we're going to start by simplifying that. So we have 1 plus 1 over x. We're going to find our common denominator again. So our common denominator is going to be x. We're going to multiply the 1 times x over x. And we're going to get x plus 1 over x. Right? Put that back in. We have a over 1 plus a over x plus 1 over x. Okay, now we're going to pull this fraction out and simplify it. So we have a over x plus 1 over x. We're going to multiply the top and bottom by the inverse of the bottom fraction. These guys are going to cancel, and we'll have a x over x plus 1. Excuse me, right? Put that back into the problem. We have a over 1 plus ax over x plus 1. Okay, now we need to find the common denominator again. So we're going to multiply the 1 times x plus 1 over x plus 1. And we'll have a over x plus 1 plus ax over x plus 1. Okay, now we're going to multiply the top and the bottom by the inverse of the denominator. Okay, these guys cancel, and we have a times x plus 1 all over. Let's clean this up a little bit. We have ax plus x plus 1. Okay, let's multiply this guy through because I do not like anything left in parentheses. And that is your final answer. Okay, let's try another one. Here we have simplify b over a plus c over x plus 1 over y. Isn't that crazy? So we're going to start with the denominator here. We have x plus 1 over y. The common denominator is going to be y, so we're going to multiply the top and bottom of this x by y, and that's going to equal xy plus 1 over y. Right? Let's plug that back in. We have b over a plus c over xy plus 1 over y. Okay? Now we're going to take this part. So we have c over x, y plus 1 over y, multiply times the inverse. This cancels, and we have cy over xy plus 1. Plug it back in. We have b over a plus cy over xy plus 1. Okay, we need to find a common denominator, which is going to be xy plus 1. We're going to multiply the a times xy plus 1 over xy plus 1. And we're going to get b over a xy plus 1 plus cy over xy plus 1. Okay, let's pull this mess out of the parentheses because parentheses drive me crazy. And leaving them in is not going to help us. So we have axy plus a plus cy over xy plus 1. Sometimes there's a reason to leave things into parentheses for a little while until you're all the way done. In this case, it wasn't going to help us. So I'm going to go ahead and pull it out now. Okay, we're going to multiply times the inverse. Okay, this cancels. And we have b times xy plus 1 all over axy plus a plus cy. And now we're going to pull this mess out of the parentheses. bxy plus b all over axy plus a plus cy. And that's going to be your answer. Okay, that's it for that lesson. It's complicated, but it's not hard. So as long as you take things in little steps and make the steps take up more of the problem as you go along, keep things in order, and don't lose the other parts. Don't lose this 1 plus until you get to it. Don't lose the a on top until you get to it. As long as you keep track of where you are and put things back into the problem, you won't have any problems with this. Okay? So try the practice problems. Let me know if you have any questions, and then do your homework. Thank you very much.